In this video, I'm going to start off by going through a few stoichiometry sample problems so that you can see how to solve for grams, for moles, or for liters, depending on what the question asks you for. To start with, we're going to look at the type of information that can be gained from a balanced chemical equation. So, sample problem number 1 shows you that you have N2 plus O2 creating NO2. The directions say to first balance this equation and then use it to determine the number of particles, moles, mass, and volume of each of the reactants in the product. So we need to balance it. I'm seeing 2 nitrogens and only 1 nitrogen in my products, which means I'll need to multiply my products by 2 at least. So now I have 2 nitrogens, but in my products I now have 4 oxygens, 2 times 2, which means that I need to multiply this by 2 as well to make it have 4 oxygens. You can imagine that there's a 1 right there. 1, 2, 2 is the balanced equation for this process. Next, I can use this information to figure out the number of particles, moles, the mass, and then the volume of everything that's happening, everything that's going in and coming out of this formula. Nitrogen. It says 1 molecule of nitrogen would react with 2 molecules of oxygen, creating 2 molecules of NO2. Moles are kind of the same thing. So particles and moles should be pretty easy to fill out. I would have 1 mole of N2 reacting with 2 moles of oxygen, creating 2 moles of NO2. Mass, it gets a little bit more complicated. To go from moles to mass, you're going to need to multiply it by the molar mass, which you'll calculate by looking at a periodic table. I'm going to say PT for periodic table. Look at the periodic table. So nitrogen, for example, has a mass of 14, and in N2 there are 2 nitrogens. So 1 mole of N2 would have a mass of 28 grams. Oxygen is 16, and there are 2 oxygens in O2, meaning that 1 mole of oxygen would have a mass of 32. But in this equation, or in this formula, there are 2 moles of oxygen, so I'm going to take 32, multiply it by 2 to get 64 grams. Last, NO2, well, nitrogen has 14, plus we have 2 oxygens, so 2 times 16, this should come out to be 46 grams of NO2. Oops, and then I forgot, we need to multiply that number by 2, since that's 46 grams for every 1 mole, meaning that I have 92 grams of NO2 in 2 moles of NO2. So in this balanced equation that we have up here. Last, to go from moles to volume, I'm going to multiply not by the molar mass like I did before, but by 22.4 liters. So 1 mole has 22.4 liters, which means 1 times 22.4 is just 22.4 liters of nitrogen. 2 multiplied by 22.4 becomes 44.8, need to cross that out, liters of O2, and then if I have 2 moles of NO2 and I multiply that by 22.4, I would get, again, 44.8 liters of NO2. Let's look at some sample problems. So sample problem number, you have nitrogen gas reacting with hydrogen gas, forming ammonia. Step number 1 is to write the balanced equation for this problem, and then we've got some information to figure out using the balanced equation. So I'm going to use the space up here to translate these words into symbols. Nitrogen and hydrogen gas are both special in that they're diatomic, which means we have N2 plus H2, and they create NH3. But I need to balance this. I'm seeing 2 nitrogens and 1 nitrogen. So I'm going to put a 2 to balance out my nitrogens. That makes me have 6 hydrogens on my product side, which means that this needs to be 6 as well, so I'll put a 3 out front. This is a balanced equation. My question says, after writing the balanced equation, I need to determine how many moles of ammonia, that's the NH3, will be produced if you start with 3.4 moles of H2. So my plan for this, I always like to make a plan, is I'm going from moles of H2, that's the number that they give me, the question tells me, and I need to convert that to moles of NH3. Should be a fairly easy conversion. There's just one step. First thing I always do with conversions is write down the number that the question tells me. So 3.40 moles of H2 is what I have to start off with. And I need to convert that in such a way to be left over. My final answer will be in moles of NH3. I want moles of H2 to cancel, so I'll put it on the bottom. I want to be left over with moles of NH3, so I'll put it up on top. And to fill in these numbers right here, all I need to do is look at the equation that I just balanced out. My equation tells me that for every 3 moles of H2, so I'll write that down on the bottom, I would create 2 moles of NH3. So I'll put that up top. If I do the math and calculate that out, I get 2.27 moles of NH3. Notice that my moles of H2 canceled out. The only unit left over is that moles of NH3. And I rounded it to have three numbers here because the question gave me 3 sig figs. So I'll use 3 sig figs in my answer. Let's do another example. Sample problem 3 says, for the reaction above, so the same equation that we balanced out, what mass of ammonia, so that will be grams of NH3, will be produced from 44 grams of H2. So let's make a plan first of all. I'm given grams of H2. Now I can't go directly to grams of NH3. That's just not possible. I'm going to need to take some kind of middle steps in converting. I can go from grams of H2 to moles of H2. And then from there I can go to moles of NH3. Squeezing it in here, but then you can see my very last step would be to convert from moles of NH3 to grams of NH3. So let's go ahead and do that. Step number 1 is to write the number that you're given in the question. So 44.00 grams of H2. My plan says 1, 2, 3 conversions from there. So I'm going to go ahead and give myself space for 3 different fractions. My first conversion is going from grams of H2 to moles of H2. I want grams of H2 to cancel out, so I'll write it on the bottom. And I want to be left over with moles of H2, so I'll put that on top. I need to fill these numbers in. 1 mole, if I look on a periodic table, well, 1 mole of hydrogen is just 1 gram, so that means 1 mole of H2 is about 2 grams, because there are 2 hydrogens in H2. 2 grams, 1 gram each creates 2 grams. Now that grams of H2 is canceled, I want to do my next step, which is to get rid of moles of H2. So moles of H2 is going to cancel out. I'll write it on the bottom. And I'll be left over with moles of NH3. I need to fill in these numbers, though. To do that, since I'm converting just between moles, all I need to do is look at my balanced equation. My balanced equation says for every 3 moles of H2, I create 2 moles of NH3. So let's fill those numbers in. The 3 goes next to the H2, the 2 goes next to the NH3. My last step, now that moles of H2 got canceled, is to cancel out moles of NH3. So I'm going to go ahead and write that on the bottom. I want to change that to be in grams of NH3, so I'll write it up top. Looking at a periodic table, 1 mole of NH3, we need to find the mass of that. We need to find the molar mass to fill this part in. Nitrogen is about 14, I'll make a little note of that. Hydrogen is about 1, and I have 3 hydrogens, so I'd multiply that by 3. So this ends up having a mass of about 17 grams. NH3, 1 mole of it, has about 17 grams. If I go ahead and plug all of those numbers into my calculator, my answer that I get, 249.3, and again that's grams of NH3. My only unit that didn't cancel out.